Okay, in this video I'm going to show you how to solve another rational inequality. Now let's talk about what rational inequality means. Remember the word rational has a root word of ratio in it. So you have some kind of a ratio or a fraction with polynomials in it. Okay, so you have some kind of a polynomial inequality that's in a fraction form, and that's why we have this one set up for us. So what I want to try to do is find all the x's that I can plug into this side that will result in an inequality that's greater than 2. Okay, so it results in a fraction that's greater than 2. Now, how do you do that? Well, your first step is to find restrictions. Now, what do I mean by that? Remember, restrictions are numbers that cannot work in your problem. And in this case, we can't put zeros in denominators. So we're going to say that negative 4 rather, is a restriction. We're going to say that x cannot equal negative 4, because if x were negative 4, it would make my denominator 0. So that's one thing we have to do right off the bat, is look at the denominator and tell me what numbers won't work. All right? Now, once we've got that taken care of, let's go back to solving this problem. So x minus 3 again over x plus 4 greater than or equal to 2. One of the tricks I like to use whenever I have denominators that are different from each other, and here I've got 2 over 1 and x plus 4 is in the denominator over here, is I like to multiply by 1 to make the common denominator. In this case, x plus 4 is the common denominator. So I'm just going to multiply by 1 over here and cross that out. And that's going to give me x minus 3 on this side is greater than or equal to, and let's go ahead and distribute that. It's 2x plus 8. Okay. Now this is pretty easy again. What I'm going to try to do is I'm going to isolate the x. So let's get all the x's on one side. Let's subtract x from both sides. And that's going to give me negative 3 is greater than or equal to x plus 8. That's my fourth step. And now let's subtract 8 from both sides. And that's going to give me negative 11 is greater than or equal to x. Or another way of saying that is x is less than or equal to negative 11. Now what this is saying is this negative 11 represents one of the boundaries, okay, of my rational inequality. Just like the negative 4 up here is a number that I can't use, I have to have an x that's going to be less than negative 11, if that makes sense. So those are my two conditions. Now what do I do with those two numbers? Put them on a number line. So let's do this. We'll make that 0. We'll make that the negative side. And we'll say down to negative 4 is right there. And remember, it can't equal negative 4, so it's going to be a circle. And let's go down to negative 11. We'll just pretend that's negative 11. And it can be equal to or less than, so let's fill that in. Okay? Now these are my three regions. Look what I've done. I've developed everything that's from here, negative infinity, all the way up to negative 11. But I can include negative 11, so I'm going to put a bracket. Sorry about that noise. Now, between negative 11 and negative 4 is another region, so let's go ahead and do that. Remember, bracket. And then finally, another region is everything from negative 4 all the way up to positive infinity. Again, notice I put parentheses because I can't include that negative 4. So now what I want to do is I want to test a point out of each one of these regions and put them back into my equation and see if they work. And that's how you get your final answer. Okay. So let's choose a point out of here. How about negative 12? So we're going to say, let's choose negative 12. Remember, this is function notation. That means that's the input. So negative 12 goes in for the x, minus 3, over negative 12 plus 4 is greater than or equal to 2. Let's see if that works. Negative 15 over negative 8, less than or equal to 2. That's actually going to turn out to be 15 over 8, less than or equal or greater than or equal to 2. Is that true? No, it's not, because that's actually like 1 point something, all right? And 1 point something is not greater than 2. So the answer is no. this region will not work. Let's try this region now. Let's test, I don't know, -5. So we're just going to choose -5. You can choose any number in between there, okay? So let's try that one. So -5 minus 3, -5 plus 4, greater than or equal to 2. That's going to be -8 over -1, which turns out to be a +8, doesn't it? Greater than or equal to 2. And that's a true thing. So we're going to say, yes, this one works. This is a region that's going to work. Any number in there will actually work. Now let's try this last region. And let's test any number in here. Let's try 0. 0 is always an easy one to use. So 0 minus 3 over 0 plus 4 greater than or equal to 2. You're going to get -3/4 greater than or equal to 2. Whoops. Sorry about that. And we can see that that's a false statement, isn't it? So the answer is no. The answer, therefore, is every number between -11 and -4 will work, and I include -11, but I don't include -4. I hope that was helpful.